First of all, I would like to thank the organizing committee for the invitation and the opportunity. My name is Fernando Reis. I am professor at Federal University of Espírito Santo. And in this presentation, I will talk about some results of the paper Milnor Hahm fibration for mixed maps. This is a work joint with Professor Michael Ribeiro of Federal University of Espírito Santo and Professor Antônio Andrade of Federal University of Recôncavo Baiano. We consider a new class of singularities called mixed maps from OCA class. In this new setting, we prove the existence of Milnor Hahm fibration on the tube and sphere. Moreover, we discuss the problem of existence of Milnor vector field for this class. For a function from Cn to C, for us, a function from Cn to C is a mixed polynomial function if it's equal to the sum, where C nu and nu are complex constants and Z nu and Z nu are multimonomials. Mixed singularities have been the objects of study of many researchers in the last years, and its systematic study have resulted in a sequence of papers. For instance, Acampo, Sead, Ruas, Pichon, Tibar, Chen, Bordadilla, Araújo dos Santos, Ribeiro, and several works of OCA. The variety of results found in the literature permit us to conclude that the mixed functions are an excellent class of singularities, which better shows the contrast between the complex and the real settings. In this summary, the studies of singularities of the mixed functions have occupied prominent positions. However, for mixed maps, it is when a target space has dimension greater than 1, not too much theory have been developed. For instance, we have the following question. Local variants used in the descriptions of mixed singularities associated to mixed functions would still be useful for the description of mixed singularities by now associated to map germs. We give a positive answer to the question stated above. In this sense, we consider the class of singularities called mixed map. A mixed polynomial map is a map from Cn to Ck such that its component Gj from Cn to C is a mixed polynomial function as previously defined. In general, in the target space, the germ of sets G of singular set of G and the image of G may not be well defined. The authors Araújo, Ribeiro, and Tibar make it clear in the next definitions. Let G from Cn to Ck be a continuous map germ. We say that the image G of K of a set K containing 0 is a well-defined set diameter 0 if for any two balls centered at 0 we have the equality of germs given by this equation, equality. Whenever the image of G and G of singular set of G are well defined as a germs of sets, we say that G is a nice map germ. Therefore, in this work, all the maps considered are nice map germs. They also give the following definition. Let G from Cn to Ck be a non-constant nice mixed map germ. We say that G has a Milnor Hahm tube fibration if for any epsilon small enough there exists eta such that the restriction G from 1 given by 1 is a locally trivial fibration of each connected component CA such that it is dependent of the choice of epsilon in eta up to the Frunhoff's. Let us remark that discriminant of J is equals to G of singular set of G. Let G from Cn to Ck be a non-constant nice mixed map germ. We say that its discriminant is radial if, as a set germs at the origin, it is a union of real rough lines of just the origin. Let G from U to Ck be a representative of the nice mixed map germs G for some open neighborhood of the origin U. We consider the map PCJ given by 2. If discriminant of J is radial, then PCJ, the restriction PCJ given by 3, is well defined for a small enough epsilon. We say that J has a Milnor Hahm sphere fibration whenever 3 is a local trivial smooth fibration, each is independent up to the Frunhoff's of the choice of epsilon provided is small enough. Let us consider U subset of R to N, an open subset such that 0 belongs to U and rho be a non-positive proper functions which defines the orange. Let G be a non-constant nice mixed map germs. The set germs at the origin Mj given by this and MPCJ defined are called the set of non-regular points of G and PCG respectively, or the Milnor set of G and the Milnor set of PCG respectively. The next condition was used in reference arch 1 and arch 2 to ensure the existence of Milnor Hahm fibration. Then the condition 4, where you use it, where the topological closure of the subanalytic set Mj minus J of the discriminant inverse of J from the discriminant is considered as a set germs at the orange. And the condition 5, we call it the condition 5 as rho regularity for CJ. In this case, we say that PCJ is rho regular if satisfies the condition 5. For any mixed polynomial map G from Cn to Ck in Cn, we consider the mixed Jacobian matrix given by J and G. Then, where D, J, G, and D bar G are holomorphic and anti-holomorphic gradients of G at the point Z in Cn. Then we give a characterizations of the Milnor set in singular set for mixed maps with the following proposition. Let GCn from Ck be a mixed polynomial map, and for any Z in Cn consider the matrix B tilde G Jm G by GMG transpose, and B defined by A and and a product for the transpose of A, where A is given by the complement of the Jacobian matrix. One has that singular set of G is given by this restriction, and the Milnor set of G is given by these restrictions. For example, we consider the map G from C3 to C2 be a map given by these two coordinates Z1 bar, Z2, Z1 plus Z3. One has that Vg, the variance, is given by this. It follows from proposition 1 that the singular set is given by Z1 equals to 0, and the Milnor set of G is equal to Z1 union this condition. Consequently, G has isolated critical value and satisfies the transversality condition for PCJ is row regular, and from RT1 and RT2 we have that G is nice, has a Milnor 2 and sphere fibration. Another example, let G from C4 to C2 be a mixed map given by the coordinates Z1, Z1 bar, Z2, Z3, Z3 bar, Z4. One has that Vj is given by this union of sets, and it follows from proposition 1 that the singular set is given by this union of the sets. The intersecton of the variance of Vj and the singular set of G is only 1, 0. Follows from RT1 that J is nice and has a Milnor 2 fibration. The next result is an immediate consequence of lemma 3,3 and lemma 5,1 of RT1 and theorem 3,5 of RT2. Proposition 2. Let G be a germ of the identity map. If F, the map from Cn to Ck, is a nice mixed map germ satisfying the transversality condition for, then the map G given by F and G has Milnor Hahm tube fibration. Moreover, if discriminants of G is radial and PCG is row regular, then G has a Milnor Hahm sphere fibration. An example, let G be the germ of identity function and G identity functions, and let F from C4 to C given by this formula. Consider the mixed map germ G Fg from C5 to C2. Then we have that F satisfies the transversality condition for discriminant of F is 0 and F is nice. Discriminant of G is 0 plus C. It is G has a radial discriminant. And it follows from R, the reference R, theorem 4, 7, that PCJ is row regular. Consequently, it follows from proposition 2 that G has Milnor Hahm tube and sphere fibration. Now we give a new definition. Let G be a mixed map germ. We say that image of G is full if it contains an open ball for some small enough eta positive. We have a technical lemma for the the proof of the first main result. Let G from Rm to Rp be a real, satisfying this condition, be a real analytic map geometry which satisfies the transversality condition 4. If codimension of the discriminants G is greater than 1, than 2, or equals 2, then the image of J is full. In particular, the topological type of the fibers does not change. So we have the first main result. Let G be a mixed map with each component function is separable variables and satisfies this relation for any J from 1 to K. Then the Milnor Hahm tube and sphere fibration exists, and the fibrations 3 PCJ, the restrictions given by 3, and the C restrictions to the ball given 6 are equivalent. Moreover, a maze of J is full when the topological type of the Milnor Hahm fiber is unique. We say that two locally trivial smooth fibration P line are said to equivalent if there exists a smooth or diffeomorphism H such that satisfy this relation, this equality. From another example, G, when G1 and G2 from C6 to C2, with G1 is given by this function, and the second component function is given by this Z5 plus 2Z5 6 bar. One has that this condition is satisfied. And since G1 and G2 have separable variables, one can apply the theorem 4 to obtain the existence and equivalence of the fibration 3 and 6. In addition, the topological type of the Milnor Hahm fiber is unique. Now we have the another technical for the proof of our second main result. Let G be a germ of mixed map given by J, Z1, Z2, Z1 bar plus Z2 P2, where each Pj is greater than 1 with J from 2 to n and J such that Pj is different of 1. Then the singular set of J equals to this union of the sets. And there exist real positive constants with such that the Milnor set is the union of singular set of J union with this set. Then we are in the conditions to prove the. Moreover, J satisfies the transversality condition 4. And now we are in the condition to prove the second main result. Let G from Cn to C n plus 1 minus 1 be a germ of mixed map given by this component, each component satisfying the same condition of the lemma above, where Pj is greater than 1 or equals 1 with J from 2 to n, and let L D set. Then J has a Milnor Hahm tube fibration. Image of J is full, and the topological type of the Milnor Hahm fiber is unique. Moreover, if L is empty, then J is 0, otherwise one has that the dimension of discriminant of J is positive. In particular, if all Pj from to when the mixed map J are equals, the mixed map J has a Milnor Hahm sphere fibration, and the fibrations 3 and 6 are equivalent. For example, let's G mix map germ from Cn to Cn minus 1, where each component is given by this relation. It follows from theorem 7 that image of G is full and the topological type of the Milnor Hahm fiber is unique. The discriminant is only 0, and J has a Milnor Hahm sphere fibration, and the fibration 3 and 6 are equivalent. Another example, among some reference, we have the campo, Araújo, Art 1, Art 2, the papers of Oka. These works was written in this presentation. Thanks.